we have, that's about Edge. And today class, it's a gift for you guys because you're going to learn how to use the Edge app that you can use for free in any of your projects. And I also going to show you how the energy modeling that we're going to do with Sapphira is going to make your life super easy after knowing what it takes to make it in a calculator like Edge. So class, we will have this workshop of how to use the Edge app. As you might know, Edge is one of the leading systems and of green building, especially in Latin America. And it's sponsored by the World Bank. I will give you a tour of how that's going to work. What we're going to see today is going to be the edgebuildings.com website. Edge Buildings. Okay, there you go. You can see my screen, right? Okay, so what we're going to do the whole afternoon today, it's a quick tour through the energy simulation tool that you have in your at your reach with no cost. We were going to see this at the end of the semester, but I think that it's going to be of great value for your projects. You can use this tool for free, and you can use this for any kind of project. And I'm gonna give you a tour of how this works. The first thing that you have to know is that this is a tool that is promoted by the IFC, International Finance Corporation. This is part of the World Bank group. The World Bank is not going to lend you money to you guys. It's going to lend you more. It's going to lend money to other banks. And the World Bank created this tool to make green buildings easy, affordable, and reachable within a generation. And they are basing their financial products on compliance with the Edge app. So this is going to become, in very near future, a prerequisite to get a loan from any of the local banks, because the local banks are going to be requested to comply with this. That's actually happening right now. We have a big project in the south of the Guadalajara. I mean, in Chapala Lake. In Ajijic, actually. It's a big project that is receiving money from a German bank thanks to the Edge compliance. And we are about to start a big office tower in Guatemala City that is required to comply with Edge in order to receive this special financial product. So this is already happening. This is something that you will have to have in your toolbox just in case you need it. Okay, so quick tour for the website, edgebuildings.com. It's on Canvas, and Luis, I'm going to post it on an email for you to know. edgebuildings.com is going to be the gateway to the different tools that are available in here. So almost any type of building can be certified. That's coming from homes, that is referred also as apartments. A light industry, that means that is warehouses and other spaces that can be considered as industry, not only big industry, warehouses where no people are in there, and offices, retail, hotels, hospitals, and schools. So as you can see, most of buildings can be certified under this. And just look at the numbers of the amount of savings that are being generated by this program. It's one of the world's most ambitious programs regarding green building, and It's supported not only by the World Bank, but also by the UN and several other universities, including and institutions, including Mexican universities and institutions. The main tool is the Edge app. We're gonna go to this in a minute. I just want you to watch this short video. I'm not sure if you're gonna listen it. Please let me know if you are able to listen to it.
Requires that a project reach at least 20% less energy, water, and embodied energy and materials compared to a base case building. Let's get started. First, we need to sign in or register to become a user of the free Edge app. To get started, we need to select the building typology from the menu on the left. Let's choose Homes. We're going to design a resource-efficient apartment building in Ecuador. Now, enter the project and sub-project details. Under the Location Data section, choose the country, city, and income category for our project. Now we'll enter our building data to begin designing our base case, such as the number of floors and the expected occupancy per unit. You will notice that the default values for space allocation appear in the middle column. Enter the relevant data for our project in the column on the right. Select whether our building will provide an AC or heating system at the time of construction. Below the Building System section, open Key Assumptions. Review and adjust the assumptions as needed. Take note that documentation will need to be provided for any changes. The cost defaults show the averages for our selected country. For accurate projections, review each cost carefully. We've now designed our base case building. Let's move on to the Energy tab to begin designing our resource-efficient building. The project's base case reflects the building's energy use before any design selections have been made. Our improved case will change once we select energy efficiency measures. As our apartment does not include AC or space heating, virtual energy reflects the eventual energy required for thermal comfort. Select energy efficiency measures and compare their costs and impacts instantly. Here, enter specific details for each measure, such as the solar photovoltaics percentage of annual electricity use. Any changes made will override the suggested improved case in the name of the measure. Click on the name of the measure to learn more. From there, access the Edge user guide for more in-depth information on the measure. After reaching at least 20% energy savings, let's move on to the Water tab. First, select water efficiency measures and then enter the specific details for each measure. Certain water measures positively impact energy savings if related to the heating of water. Let's proceed to the Materials tab. This section calculates the amount of energy required in making the construction materials for the building. We're required to enter information for each materials category. Select materials from the drop-down menus. If the project has more than one material for any of the categories, use the proportion field. Next, select a material for wall insulation. This is required as we selected external wall insulation as an energy efficiency measure. To see the baseline assumptions, such as for the floor slabs, click on the name of the category. Here, alter the thickness and steel rebar as needed. Our building has met the EDGE standard, and at over 40% energy savings can be certified as EDGE Advanced. Let's check on our incremental cost and payback period. Our results tell us that each unit costs an additional $703.76 and takes less than 2 years to pay back through utility savings. The projected utility cost reduction of $30 per unit is the value that can be marketed to home buyers through the EDGE certification. Once we save our project, we're ready to register for certification.
Okay, I hope that was interesting. Maybe you didn't notice at the end part that the Swiss government and the UK government, the United Kingdom government, is paying for this also. So that's another advantage that we have now. I want you to show you how we're gonna fill up that form in order to make you start. I want to get into this. The UK government and the Swiss government is paying for this. So this is a big project, a big rich countries project. They are helping to the developing countries to reach their goal for green buildings. And I'm saying this because EDGE is not allowed to be used on the UK or in Switzerland or in any other part of Europe, the US, Australia, or Japan. It's only for developing countries. In here, I want to make sure that you know this little tab in here, user guides. I'm going to show you another way to get in there, but this is going to be one of the most useful textbooks that you're going to have regarding sustainable construction. Okay, continuing to the tour, I want to go, I'm sorry to move in here. Okay, before we get into the projects with some of the examples that I want to show you, I want you to know how to get into the EDGE app that is in this corner, or, okay, it took me too long. I need to make another login. Hopefully I have no trouble. Okay, and open projects. I just have one that it was already done. Hold on a second.
Teacher, does this work for Mac?
Sure. It's on browser. You don't need to install anything in here. Okay.
Okay.
In here, yes. Okay, so this is optional. This is not going to count as part of your grade, but I strongly recommend you to make this exercise. It's going to be based on the exercise that is going to account for your grade, but that's on the third term. I'm putting this a little bit up front in order to give you a little bit more time to understand how that works. You're going to create a new project and you're going to name it your first initial thing here, and then office tower like this. Okay, this is energy efficiency, energía y eficiencia energética en edificios, agosto-diciembre 2021. Okay, that's the way that I can find the project, because you're going to share it with me, not exactly now, but at the third term of the semester. Okay, I already made an example for you guys to be prepared for this. So for the exercise that I'm proposing, what you're going to do is to copy the same parameters that are in here, and I'm going to guide you bit by bit how to get in there. First of all, take into account this side of the bar. This is letting you choose the type of building that you're going to use. This time we're going to use offices. And what is interesting about Edge is that in order to make your life easier, it's going to guess most of the parameters that are in there. You don't need to have to know everything about your building, exactly as we're going to do now. Okay? So just for you to get familiar, the example that we're going to use in this time is going to be the Torre Bansim. I'm sure that most of you know this building. This was made by Alberto Kalach. And I have to say, we tried to make a LEED certification with this, and they refused, in part because Alberto Kalach, we know him, he's a very talented architect, and he is very careful regarding building science. So it's very likely that they don't need the certification, and on top of everything, the Torre Bansi, it was made for their own client. They don't need the benefits of certification. We're going to use a building that is close to this one in order to make the example both for Cefaira and for Edge. Okay? So what I want you to notice from here is the north and south facade, that is this one that is here. Notice that it has two sections on the edges that are blank, that are solid, and then you have the whole thing in the middle window with the columns outside. This is a very weird building in that sense, but it works pretty well. So it's very helpful to make some of the examples that we're going to try to do, and it's going to be fun for you to focus on a building that you already know and you might visit in the near future. Okay, so from here, besides the facade, what I want to show you is the plan. The plan that we're going to use is more or less like this. And what I mean more or less is that we're going to avoid these funky angles that are in here. That's in order to make your life easier. So it's going to look like this, but in a straight manner. Okay, this part is going to be completely straight. This is a 90 degrees angle. With that, I'm going to make easier for you. But if you want eventually to make it as funky as it is in reality, that's okay with me. What I'm telling you that is a weird building. Hold on, I think that I have someone on the. Okay. No, it's not on the waiting room. I think so. Hold on. No. Sorry about that. Okay. So what we're going to do is use this plan. And I'm telling you, as these were 90 degrees angles. What is weird about this plant, and is very efficient in that sense, is that it creates a very narrow a distance between one facade and the other. Of course, it's cross ventilation, and it's also, that's right, natural light. Okay, so this building, the shape of this building is helping to achieve both of the most important things regarding a green building: natural light and ventilation, cross ventilation in this case, and it's concentrating the stairs, lifts, and other services on the corners. Sorry about that. It's concentrating the services on the corners, and this architect, Kalach, even if he's from Mexico City, he knows for good the impact that sunlight and the radiation has in this city. So he cleverly blocked most of the light and heat that is coming from the east and west facade. This is the north. North is all the way upwards. Okay, so we're going to use this plan, and instead of using these funky measurements, I put it easier for you. This is going to be a 6, and this is going to be, the total is going to be 50. That's only to make your life easier. We're going to round up things. Okay, so we're going to be based on this plan, but it's not exactly that plan. We do have this columns on the facade, and that's going to work for the window-to-wall ratio. That means that from this facade, let's say this is the south facade, to calculate the window-to-wall ratio, you have to take out this part of the facade, because it's not counting as window, and all this part of the columns. You see? The rest of that is going to be window, so that is going to count as the ratio of window-to-wall ratio. Okay. That's just for your information, and I also wanted to show you a little bit of the project just to get a little bit excited. It has a very nice rooftop. We're going to count everything as office space for the sake of the exercise, even if there are other uses in here, like that there is a bank in here. We're not going to count this as a bank. We're going to suppose that the whole thing is office. That's going to make things easy for you. Okay? Did you knew this project? Did you like it? It has become an important part of the skyline of the city, so I think that it's a very interesting building. And once again, the work of Alberto Kalach is super interesting. I strongly recommend you to take a look of other things that you have worked in here. And I'm using this also for another reason. Something like 15 years ago, I was working with an architectural firm in Mexico City, JFA, that's with Javier Sanchez. And we were in the competition of this building, and we lost. And when I got to know the project that won, that is this one, it's 15 years old already, I was very glad that it was much better project than ours. So I'm very proud to use this building as a building that won on the competition. Okay, so what we're going to do is to use the Etch app, and we're going to mimic what is happening in here. So the first thing, and please try to copy this, I'm going to try to send you most of the information, but it's going to be quite obvious when you see it. First, just to get familiarized with the tool, make sure that you're on the tab Offices, okay? And make sure that you name the building properly, otherwise it's going to be super difficult for me to understand how that's working, okay? So the important part of this is the save button. It's very annoying, but it will log you out. So if you don't save it, you will lose your project. Make sure that you keep saving the project, and there are some times that is demanding information in order to save it. Don't do other things unless you finally save this, if not, you're going to lose the progress that you have. We don't want that. Okay, what you're seeing here is the final energy use, and look at this. This is measured in kilowatt hour per month. You will see in Sapphira that is measured per square meter per year. So in order to have the same number that you have in Sapphira, we will need to make a very quick calculation with this and use the same units. I'm telling you this because it might look very different, the result from Sapphira, than this one. But at the end, the calculations, they tend to have a similar result if you have the same parameters in here. It's just the unit that is changing, okay? We're not going to see a lot of water, and we're not going to see a lot of materials. Just a quick tour, as in the video. We're going to focus most of our tour on energy, okay? So utility cost. Remember that utility cost is referred as electricity, gas, and other possible energetics that you have in here, including water. Make sure that you have the right rates, Mexican rates, the CIAPA and CFE rates, in order to have the true cost of this. But this is going to be really useful because you can tell your client right away how much it's going to cost him to operate their building, and of course, what are the savings that you're going to help your client to achieve. As you can see now, we're just starting, so we're not complying with it. That requires 20% in each category, but we're already saying to our client that he's gonna save 16,000 pesos per month with the proposal that we're making. I'm gonna show you how this number is gonna become much less important when it comes to the decision for green building, because at the end of the semester, we will have the experience or have the true cost for people that are gonna be in there. Be very careful with this number in here. Incremental cost, this is taking into account a standard cost for material. So this one is tricky. And this one depends on this one. Payback in years, it means the amount of time that is going to take you to achieve this incremental cost with the savings, okay, to reach into this. So far, it looks like it's really close. I will tell you how this number is got, but we're not going to base the results in this one, okay? And we're going to go with the data that you need to put in here. The first tab is design. You're not going to be able to go much further if you don't fill up this right. This is really easy. Mexico and Guadalajara, you will notice that not all cities are already listed in here, but a lot of them are. So you can use this in a lot of cities in Mexico. So far, to have the same results, even if you are in a different city, please choose Guadalajara, okay? Project details, we're gonna summarize this in a very easy manner. Please use this address. This is the right address that is for the building, but it's important because it's gonna let you use the weather station that is near this address. So this is the actual Torre Banfi address. This is the actual postal code. Try to use this. If you get lost, just Google it and you will find it. You don't need to share this with banks. No, it won't make a difference. They are not going to see this information unless you apply for a certification. So you are free to use this tool and no one is going to take a look at this. No worries about that, okay? Put your name, the city that is in here, and if you don't want to put your phone, that's okay, but I recommend you to give this data to these guys because it's going to be useful in the near future. For example, I am a lead expert, I am a lead auditor, and I get calls from the IFC offering me projects. So if you're listed in here, it's a good idea, okay? This is going to be the amount, the square meters that we're going to use. As you can see, you can't modify it in here because it's coming from a little bit further. This is like a little summarize of the building, okay? Use your tech email, please. Put it in Jalisco, and it doesn't matter if you put yes, not sure. Put it not sure so you don't get scared about this. We're not going to use this too, or this one. The only thing that I recommend you is to save all the time, okay? And remember, it will take you out after a few minutes. It's really annoying, so try to save it. Okay, now, sub-project details. This is important to let you save. Use more or less like this. Once again, if you want to use a different name, that's okay, or a different email. I recommend you to use the right email because for this class, you're going to need this on the third part of the semester. For the building data, we're not going to use any parking space. Okay, this is not like the regular calculations for office building, but in order to make your life easier, we're going to use this. And we're going to use the default densities and hours that are in here. It might not be the right ones or the exact ones with Sapphire, so we're going to jump from these to Sapphire. Okay, So this is going to be our default, our baseline density, and it matches with the Mexican way of doing things, you will see. Okay, 33 floors. As you can see, there is 1,000 square meters per floor. No floors below grade. This is different as a project, and we're going to use actually, we're going to use four. Sorry about this. Okay, 4 meters for floor to height to make your life easier in here. As you can see, the occupancy density, it matches the one that is traditional in Mexico. 12 square meters per person of usable space. This is different than the one in the US. However, this is a regular density pre-pandemic. I'm pretty sure that after the pandemic, this is going to change. 10 hours a day, you're going to be using 5 days a week. We don't work on weekdays, on weekends. And the whole year, we have 12 holidays. This is going to give you the overall energy use. Even if you can modify it in here, please try not to do so we can have the same data based in here, okay? Try to avoid these two little checks in here. And as you can see, H is going to help you to make a wild guess of what's going on inside your building with the regular uses of building, of an office building in here. We do want to make a modification in here, but we're going to leave it, let's see, there you go, no private office. Everything is going to go to the open plan office. And save it. Okay. Please leave all the rest as is in there. And very careful with this. This part is going to be very important. And this one you will have to modify. Sapphire can't guess it. I mean, Edge. Edge has a built-in energy modeling tool. So it depends a lot with the information that you're giving. The building length, it means how this facade that is facing north is shaping the building. So for the north and south facade, please say that you have 50 meters and east and west 20 meters. This is the only thing that you need to modify. As you can see here, main orientation is north, and this one is going to be coming from this. You can always change it in here. It's not required this time. We will make that a little bit further. Okay, in building system, the only thing that we're going to modify is that there are no heating system in here. And in key assumptions, we're going to use the CFE, cost of electricity. This is in US dollars per kilowatt hour. So this is more or less a, hold on a second, no, I'm sorry, this is, my bad, it's 0.2, it's 0.2, yeah, 2 pesos, yeah. It's 20 cents of kilowatt per hour, that is more or less 4 pesos. That's what is usual in an office building. Of course, it depends on many things, but this is a regular one. And we're going to use only the cost of electricity. Okay? Try not to move the temperatures that are in here. Remember that these are average, and this is taken from a weather station near of the location of the building that you already said. So please try to leave this as it is. Don't modify this, even if this is going to be really important. So far, leave this as it is. Okay? I'm recording this so you can come this as many times as you want. Just make sure to click save and not lose your progress. Okay, so once you have this, you have already what is required for energy simulation in the Edge app. So I'm going to show you not how the whole simulation works, but the one that I think that is going to be most useful for you. So we're going to go to the Energy tab, and you're going to get familiarized with a lot of these different options that are in here. And look at this. It works with this click and unclick of the different things that are in here. Okay, there are a lot of options to be taken in here. We're going to work only in two of them. Okay, the first one, that is OFA 01, reduced window to wall ratio, and the number 4, external shading devices. The only one that you need to make changes is going to be the external shading devices. For the first one, I want you to fill up like this, okay? This is taking into account what is the amount of window in relation to wall that you have. And you can always go to the Edge user guide. I'm going to show you how to get in here in a minute. So please use these values: 80% window on the north part, 80% window on the south part, only 10% on the east, and 10% on the west. Okay? As you will see, this is already affecting the performance of our building. You can see that every time that you click and unclick in here, it's going to change the result for the energy simulation. And I want you to see the difference in here. We have base case, that is a building that is based in parameters according to the code. And then we have improved case. These are the elements that you're going to modify and that you're going to see what are the effects of the different options that you have in here. So far, we're going to work only with two of them, and only you're going to make modifications in one of them. Okay? Following in here. So you will see this line in the middle, virtual energy for comfort. This, what it's saying is that it's not allowed to say that your building is not going to need air conditioning or heating. The energy modeling has to prove it. The logic in here is that even if you say that your building is not going to need air conditioning, but is not well designed, it's very likely that the user is going to install an air conditioning before abandoning the building. So you're going to use a lot of energy to keep it usable. So far, as you can see, only 3% of hours are needed for heating in Guadalajara. It's very low. Air conditioning is not needed now in a virtual way because we said that we had air conditioning. If you choose, for example, no air conditioning, there is an option in here that is this one. You will see the difference that is going to appear in here regarding the energy consumption in here. But we are saying that it's properly designed, and that's what I want you to understand how it's going to work. Okay, so please try to set up these parameters in here. And once you have it, we can move on this one to show you how that's going to work. 80% east, north and south, 10% east and west. This makes the tower looks like this. If you see what I mean, this is 80% with a glass window, only 20% is not window, and on the sides, it's only 10% what is window. This is a weird building. Usually, this is more evenly distributed. In this case, is working properly because of the skills of the architect. Okay? So the one that you're going to modify and you're going to choose how you're going to do that, it's the number 4, external shading devices. And H works with an annual average shading factor. And I'm going to show you how to get into this calculation. It's not an easy one, but I want to go deep into the guide, see how this works. Okay. So you're going to see here that these are the options that we have in order to make the program understand how that's working. We're going to use the calculator. And for this, we're going to have to put every window that we're going to use, and the one that you're going to modify is this one. We have 3 options: horizontal overhang, vertical overhang, and combined overhang. And in here, you have 4 options. You will see in Sapphire that these are unlimited options. In this case, they are giving you only these 3 plus these 4 options. This is the type of overhang. Overhang stands for parasol or other shading devices. And this is the type, and this is the depth or the size that is in there. Okay? And it's giving you like easy options to choose. What I want you to do in this session is to learn how to use this calculator based on the, I'm going to show you how to get in here, on the user guides. There are 2 ways to get into the user guide. One is clicking in on top of the name. If you click in here, it will get you directly to the user guide. Super easy. There is another way to access this. I'm going to show you in a minute. Is the one that we saw at the beginning. That is all the way when you scroll down. If you go to the user guide, you will find it in here. It's the same one. Okay? So once you are on the H user guide, you will go to the external shading devices. And look at this, how it matches with Offices 04. This is the one that we're looking for. If you click on the app, it will take you straight into here. Okay, what is doing in here is taking into account these 3 factors that I was showing you. First is the combination of vertical shading, horizontal shading that is in here, and what are the measurements of this. Okay, it's going to take into account the total height of the of the window, and because it knows how what's the height of the window, it knows what is the depth. We already told the program that this has a window that is 4 meters high. Remember, when was that? We set up each floor that is measuring 4 meters. So what is taking into account H, and that's on the calculator that is in here. Sorry about that. Okay, in this calculator in here, is telling you if you, sorry about that, if you have an horizontal overhang in here, and you are saying that it has H 1 to 1, that is the same height, 4 meters, for the depth. Okay, this is by far the more efficient. This means that if this is 4 meters high, the overhang that you are proposing is 4 meters long, or that you have 4 overhangs of 1 meter. The effect is the same. You see? What it's talking about here is about ratios. not exactly about the measurements. The measurement is already given. It's 4 meters per floor. Okay, so even if it looks really complex, this formula, it's super easy. It's taking into account the same shape that you have. You see, super easy calculation. What happens in here? So when you tell this to the program, what you are saying is that it has either one that is a quarter of the height, that means one that length 1 meter, or that you have 4 that are 25 centimeters, or that you have 10 and they measure 4 centimeters each. You see what I mean? It doesn't matter because it's a ratio. And the shade is going to work the same if you put 1 that is the whole thing, or 4 split by the number of meters that you have in here. You see what is the difference? Okay, how that works? Okay, now the equation that they are using is heat gain from a window that is being shaded, and the heat gain without shading is the difference. So you're going to be compared to one that has no elements to shade to the one that you are using. That is what is required in this part. This is the, this is this number in here. It's an average of what is being shaded and what is not. You see, this number is the one that I want you to get. In order to get it, we need to make these calculations. Okay, the beginning is going to look really difficult, but this is because this table is using northern hemisphere and southern hemisphere. Okay, make sure to take into account what is the latitude. Who wants to tell me what is the latitude of Guadalajara?
22.
You know, yes, perfect. So we are in here, right? And if you are in the northern hemisphere, you can forget all these guys that are in this dark color. You see? So the only one that you take into account is the one that are in the light color. It's super easy. It looks very complex. It's quite easy. Okay? And following in here. So on the north facade, if you have a relation of 1, you will have this 0.47 on the north facade. You see? That way you can go for each one of the facades that you have. You want to ignore all these that is not your latitude. You want to ignore everything that is dark color because that's for the southern hemisphere. And you get with 16 values out of this chart that is in here. It looks complicated. It's not that much. It accounts for the same with vertical shading, and there is a combination in here. Okay, so that's going to depend on your choose of the shading elements that you're going to need, that you're going to choose. These are some examples of what they are talking about: horizontal shading, regular overhangs, vertical shadings, they combine. Okay. There's an example in here. So what I want you to do is to follow this example from protection, shading protection that you use on the storm board. Okay, remember, this is for you in order to learn how to use this tool. It's optional if you want to use it. For those that want to have feedback with me, what I'm gonna need to do is you please share the project in here. Sorry about that. There you go. Once you have uploaded in here, you can put it save in here and you can share it. I'm gonna show you how to do that. Wow, I lost that one. Sorry about that. Show the song. Oops. It will come. I will find it out. Okay, so exercise for right now. In the yeah, I see it. You need to complete the whole thing to share it. Okay. No. There you go. It's in here. Okay. So to share it, just put my email in here and I will receive it. I'm going to give you, I'm going to continue with the tour of the energy saving measures and water and materials real fast. Just let me know once you are in there. There is these different options: reflective paint for roof and walls. Remember, this is albedo. It means the amount of light that is reflected. So this is like bright white painting. It does have an impact on the building, but you will see that being a very high building, the impact is going to be super low, and you're going to see it in here. It's very unlikely that it's going to make a difference. That's the whole idea of this calculator, to help you take these informed decisions bit by bit. Everything you can come into the reference guide to understand what they are talking about. Some of the concepts are not that easy to understand. Telling you about the different options that are going to be here. We're going to work only with the ones that are regarded for architecture. This is talking about the insulation of roof. This is the amount of heat gains that can go through the roof. In a building that is so high, it's going to make very little difference. But in a building that is this high, the walls are going to make a lot of difference, especially if we have this amount of solid space. So this is taking into account this. This is the type of glazing that we have, and we have several options, and we can modify the solar heat gain coefficient in here. That's going to be also very useful when we jump back and forth from Sapphire to Edge. This is the one that I was telling you about. When you select this, natural ventilations with no air conditioning, it will appear a virtual energy for comfort. This means that this is not a free pass for not having air conditioning in your building. In here, they are telling us that 23% of the energy is going to be wasted anyway in air conditioning, even if you don't put it, because the users are going to put it. However, if we manage through passive solutions to get this virtual energy for comfort down to zero or very little, you will see that the impacts of energy consumptions are great. It's not easy. We will get into this option a little bit further when we have this sorted out, okay? This is a weird thing in Edge, and this is coming from other warm countries. Ceiling fans for office spaces. Even if it sounds really crazy, we have already done this in Edge certified buildings, and it works pretty well, and people tend not to notice there is a fan on the building. Okay, there is some options with the coefficient of performance. This is regarding air conditioning. This is a little bit too advanced now to explain. This is how efficient the air conditioning is. There are some cogeneration measures. This is also quite complex. It's making air conditioning go more efficient. We will have a guest that is talking about air conditioning. So that's something that you can ask, how we reach a COP or coefficient of performance of this. Recovery waste heat from generator. This is for space heating. We don't have space heating, so it's not going to make any difference. The type of control that you have for cooling towers. The recovery from the temperature that you have. This is usually for heating. As you can see, it's in purple, all those that are accounts for heating. And this one, it's a very important one that I want you to notice. Air economizers. This means that there is a way to program the air conditioning system that makes outdoor air come inside the building if it has the right temperature and humidity. This means that the building is working without the energy required for air conditioning with the mechanical system. This is making buildings very efficient and, on top of everything, very safe regarding the COVID and other respiratory illness. We measure this with CO2 tests, and it's very effective. And in Guadalajara and not many other parts of the world, it's useful because we do have the right outdoor conditions, especially low humidity and in the right temperature. Okay, and there is a whole section that is about lighting. This in an office space have a huge impact. I will show you just a few examples of what happens if you put, for example, this one. Look at this, how this number is going to start moving quite fast. In here, as you see, external spaces, and look at some of these occupancy sensors in open offices. Just that, just the sensor, is taking the building like 7%, making the building like 7% more efficient. This is super useful to help the client understand what is the amount of money that he's going to save by this and the upfront cost that he's going to have. So it might be, for example, that this one that is not affecting a lot in the energy efficiency of the building, it's expensive. So you can tell your client, don't go for this one, go for this other one, for example. In other cases, it could be the other way around. So this is very useful to help to take informed decisions in here. And finally, this is the renewable energy options. Of course, that you can go in this for photovoltaics, and you can go all the way to 100%, and it's going to tell you the capacity of the system that you're going to need to have. Of course, this way is going almost to 100%, almost, because we're spending a little bit more with the things that we've done. But this is, of course, the last resource that you can have because it's going to be very expensive. And of course, if you are providing 100% of renewable energy to a not very efficient building, it's very likely that it's going to be costly and not very feasible regarding financial terms. Okay, this is another option. This is, for example, off-site renewables. That means that you can buy from to other company their renewable energy. This is not going to make a lot of difference in here, but it's going to make a lot of difference in the amount of CO2 that is produced by the building. Okay. Smart energy meters, that's going to account only when it's available by the utility company. Currently, CFE is not taking into account this. Okay. So, questions so far? Does anyone want to see their case? They are already there. You need help sorting this out. Otherwise, I can give you a few more minutes to give you the tour about water and materials.
Okay.
Okay. So I'm going to continue with a quick tour for this, just to end of this. In the water section, you're going to see much less options, but the concept is the same. You have improved case and base case. So this is the one that you're going to go on. Look at this, for example, in this kind of buildings, to have a water efficient, let's see, urinals, water efficient urinals. This is mingitorios. You can change the amount of liters per flush. For example, the dry urinals that go for 0, you can put in here 0 water used by that. And I want you to understand the impact that that's going to have in the improved case. Just look at that. Just by changing the urinals to 0 water, you can reach the what is required for the EDGE certification, 20%. Of course, the whole idea is not to stop in here and also go for the dual flush water closets. Look at this. It's amazing amount of energy, of water that you are saving. This one, it's a less important impact, but anyway, it's going to help in here. And at the end of, look at this. All this is 0 upfront cost, 0 increase in upfront cost. All these guys cost the same. Costing the same, it can give you 43% of savings in this building. You are not making your client spend more money, just to take the right decisions. It's very important to have your client to take these decisions. Then kitchen things in this case are going to be very little impact. It's very unlikely that it's going to make any difference in here. After this, you can have these options that you can go all the way to 100%. For example, rainwater harvesting system. This is not going to cost much more because CIAPA is already making you make this. However, look at this. It's talking about the roof area. Okay, in this case, that is such a tall building, it makes very little difference, even if we have 100% of the roof area as a rainwater collection. This one is going to make a whole difference, but this is already involving a wastewater recycling plant. Not all clients are ready for this. And we can go this as ambitious as we want. And as you can see, we can reach almost 100% savings in water with very low cost. This final two, this can be challenging. But as you can see, if we take that out, if we take this out and the other one, these are the ones that might cost a little bit more for your client. If we take that out, we can make buildings that are almost 50% less water consuming than regular buildings with no extra cost. We already have the experience of a client that went for these two guys in here, and the building is completely disconnected from the water system. That's a great achievement, and for our client, it is giving not only the reduction of the taxes to connect to water. This building is in Mexico City, but it's also giving the building the chance for resiliency. It means that if there is a water shortage in the city, that it's very likely that it's going to happen in the near future, not only in Mexico City, but in many other parts. You don't have to stop the operation of the building because you have your own water. And just think about, if you have an office with no running water, you can't operate the building. You have to shut down. That's another quarantine from that building until you get water. Of course, you can always buy water with tanks, but it's expensive. Okay, so the final section of the edge up. You're seeing here that we have this green arrow in here. This means that we are above the 20% that is required to comply with edge. In materials, of course, you can go negative because in this case, we have so much more glass than the baseline building. So our building is performing even worse than the baseline building. We need to achieve 20% of improvement. One of the very easy way is that you try with or you intervene an existing building. If you have an existing building, there are enormous savings in here. For example, let's suppose that this is an existing building. It's not, but let's suppose that is. There is an option in here that is pre-use of existing floor